although the technique may be different. Some techniques may be applicable in some contexts, other may be applicable in other contexts like this. But yes, we can apply it. So, like in whether it is agriculture or it is uh, health care sector or anything like fraud detection or for any sort of task, it can be uh, we can apply the machine learning techniques. So like these are the some popular example, like this machine learning techniques can be used extensively used by these recommendation engines used by this Netflix or Spotify, such type of companies. This automated cars developed by Tesla, Google, facial recognition services deployed by this Facebook and other social media sites. And there are many more applications of this machine learning techniques now we can see around us. Okay, so there are different reasons why this machine learning is gaining popularity. So there are few reasons. There may be many more reasons, but the important reason is the day by day we are getting the improvised version of algorithms. Their abilities enhanced periodically, so they can solve the more problems, more complex tasks can be solved using these algorithms. Second thing is availability of open source ML libraries. Means if we are not expert of coding or computer science fundamental, then also we can use such type of open source library free of cost, and up to some extent we can solve our problem or we can get the expertise. So availability of plenty of open source ML library is also the one of the reason. Now machine learning is a not new field, it is very old. The first the machine learning term was coined in way back in 1959 by author Samuel, but now it's getting in last decade it gets mm, popular or getting more and more popular because of the availability of data. As we are saying that data is the fuel for machine learning algorithms, so nowadays the data capturing technology is significantly improved. Like we are capturing, like images can be captured easily by mobile phone, sound can be captured, or the different types of networking, fast processing device, sensor devices are available. So now availability of data is more convenient, and this availability of data as well as data capturing technology also propel the growth of this machine learning. And as well as the demand for the self customization to the user environment is also the one of the reason. So here we can see the landscape of this machine learning algorithm. So here you will observe that there are different types of machine learning algorithms are available, from like it's a supervised, unsupervised, reinforcement learning. Again, supervised maybe classification algorithm, regression algorithm. Then more specifically, like suppose for example, we are saying that many times we said that we apply the decision tree. But decision tree is a family of algorithm. Many decision tree algorithms are available like CART, ID3, C4.5, C5.0, J48, decision step. Many sort of decision tree algorithms are available in this family. Similarly, for dimension reduction, regularization techniques are available, ensemble techniques are available, deep learning methods, lot of deep learning methods are available, instance-based learnings are available. So it means that there is a vast landscape of these machine learning algorithms, and the tools are also available. So most of these tools are available as MATLAB. Most of the machine learning algorithms are implemented in MATLAB already. Libraries are available. If we cannot afford the MATLAB, then it's open source Octave is available. Similarly, for this boosting algorithm, different libraries are available, and in scikit-learn different libraries are available. So this is the glimpse of what facilities tools are available for machine learning. So uh, as we are aware that there are different types of machine learning models, machine learning algorithms. So how we can categorize them? So there are the different ways of categorizing this machine learning model, like what data is available, how we are getting the data, what are the types of model. So again, these are some primary criteria for classifying the machine learning model, although we may include more criteria. So like on the basis of availability of data, the machine learning algorithms are classified into three categories: supervised learning, unsupervised learning, and reinforcement learning. There are other options, but these are the major classes. So the basic premises of supervised learning is the data is available in labels. Means for training data, we know this is the input and this is the output. And with the help of this set of input output, like data, feature vector, and label, we train the machine learning algorithm, and then we'll test the machine learning algorithm. Again, this supervised learning can be of two types. If our labels are available in discrete, then such type of algorithms are known as classification algorithm. If labels are hello, yes, hello,
Sir, okay, sir. Yes, sir, proceed, sir.
yes,
Please go
yes.
on
Somebody
forward.
wants to ask something? Yeah, please. Hello. Yeah, please proceed. If any, someone has raised the hand, if you want to ask the question, please. Okay. I'm audible. Hello.
Yes, audible. Audible, sir.
Okay. So here, like what we are discussing, like supervised learning, there are two ways of supervised learning. One is classification, for classification tasks, and for regression. So how we'll differentiate means which one is classification, which one is regression. So we'll check the labels. If labels are available in discrete form, like discrete labels, like some classes available like 1, 2, 5, 10, then this discrete categories will say this is a classification label, like this is classification task. But if labels are available in continuous value, or we guess in the real values, then we'll say this is the regression, like stock price prediction or house price prediction. So stock value can be of anything. There is no classes are defined. Like stock can be of 1 to stock value can be of 1 to 100 or 1 to 1000. It can be of anything. Any value can be possible. So stock price prediction is known as regression problem. And similarly, like we want to classify the student categories, good, very good, excellent, or student grades, then irrespective of the number of classes, these classes are fixed, discrete in nature. So these problems are known as classification problems. So what is the template of doing this, solve the supervised learning, how the supervised learning algorithms will work? So for example, we may take any example like this spam filtering. Every day we are using in almost every email services has deployed this learning model. So we receive the email, automatically some emails will be sent to the spam folder. So how it will work? So first we will collect some email, and then we will extract the feature from the email. So feature can be extracted from the subject of the email, from the body of the email, or even email addresses itself. Like email addresses, if suppose nowadays you may also, many people are getting email like the fraud notice or CBI notice or income tax notice. So easily by looking at their email ID, we can understand that these mails are fraudulent email. There is no relevance, or there is no substance in such type of email. But yes, many people are unable to understand, and they entertain such type of people. Like somebody will say that yeah, congratulations, you win a lottery. Okay, so those who are less exposure, uh, they may be in that trap. So we, as expert, we know that. Why we know? Because every day we are dealing with such type of email. So we very well know that by looking at their header, the way of writing. So similar, the same ability can be transferred to the machine learning model. We can train the machine learning model, like machine learning model will understand the what is the email ID. If suppose we are getting the income tax notice, then what should be its email ID? how it looks like, its a line, its subject line should be what, its content should be what, like this. Okay, so here we have to extract the feature from whether it is text document, whether it is image, whether it is sound file, or for that matter anything. So we have to extract the features and will form a feature vector. So extract the feature means like we will extract we will identify the attributes. An attribute may lead to the multiple features. One attribute may lead to the multiple features. So what is the difference between attribute and feature? Attribute is used to define the problem, or attribute may represent the one column, but at the same time attribute may lead to the one feature, and feature is basically numerical values, and these numerical values may be presented in form of feature vectors. So like salary is a one attribute, so it can be like mean salary, highest salary, maximum salary, it's like this different types of features. So this ultimately this raw take in place of raw data will feed the feature vector to machine learning model. We also give the labels, like we have a historical record of email, like this we have 10,000 emails, and as expert we have labeled them as this email is a fraud, this email is a spam and ham. So this email is a genuine email, and so in this way, this label data will be. It means text, email, as well as their labels will be fed to the machine learning algorithm. This machine learning algorithm can be of any supervised learning algorithm, and then this algorithm will be converted into model. So trained algorithms are known as model. Means once we have provide the training data to any algorithm, this algorithm will be converted into model, and now we can test this model for unseen data, like for those we don't know the result, we can provide this data in form of feature vector, and we can get the label and compute the error there, what was the expectation, and what is the predicted value. So in this way, this supervised algorithms will work. But in supervised algorithm, there is no labels are available, because labels are not always, like the cost of labeling is very high. Sometimes the experts may not available, or just because of the time. So many real-time data are available without label. So yes, machine learning models, many machine learning models can work without label, and there are many examples of supervised learning tasks like clustering, dimension reduction, or we can say the association rule mining. These are some popular algorithm. Again, further there are many clustering algorithms, many dimension reduction techniques like PCA, TSNE, LDA. So there are different techniques are available. So here, if you look it closely, then you will find that there is no one thing is missing only as compared to previous, this label part. Otherwise, the rest of things will same. So here, the algorithm itself algorithm will itself will determine the uh, patterns within the input data, and it will identify some patterns, and it will reach to the uh, conclusion that these are the differentiating features. So like they can form the clustering. Suppose you have given a different mixture of in a basket mixture of fruits, and you don't know which type of fruits, and only on the basis of your common sense you have to classify, okay, which type of fruits are there. So what we'll do, we'll check the size, their weight, their color, their texture. Okay, the fruits may be of one type, but on the basis of these attributes or these features, like their color, their weight, and their taste, if not allowed to taste, then in that case texture and all these we can categorize the food. So this is the way of unsupervised learning algorithm. Similarly, the one more very popular nowadays, this reinforcement learning. So this reinforcement learning is basically a reward and penalty. It's working on the basis of reward and penalty, and here the learning system is known as agent. Okay, so agent will observe the environment and select and perform any action. So in response to that action, it will get, either it will get reward. If your action is correct, then you will get reward in return, or if penalties in form of negative reward. Suppose a driverless car is moving. So on the basis of what this as an agent, it will sense the environment. On the basis of that, it will take any action. So this reinforcement learning is also the reinforcement learning has huge application in many fields like game playing, this robot path planning, and this some popular games are also developed. So here you can see how this reinforcement learning will take these. So here, like we are discussing how a medical problem can be solved by using the machine learning. So here you can see like these are the MRI images and the labor data set, and we can extract the different number of features and train the model and use this trained model is supervised way, or if unsupervised way, we also heterogeneous patient population and multimodal patient data can be extracted, and on the basis of this clustering we can classify the different types of patients. And these are things like how we can apply. This is one example. Now the second way, this is only on the basis of what type of data is available. So it can be of supervised, it can be of unsupervised, or it can be of reinforcement learning. But there are some more like semi-supervised learning, active learning, or you can say transfer learning. So there are different types, many more types of learnings are there. But yes, these are the fundamental learning techniques. Similarly, the machine learning models can be classified on the basis of whether these models are parametric or non-parametric. So parametric model will summarize the data with set of parameters of fixed size. Means what it means the if your model is independent of number of training example, then such type of model is called the parametric model. And means it will not consider how much data you feed into parameter. It will not change its core assumption about how many parameters it needs. And non-parametric model means the models have lot or tons of data and no prior knowledge, when you do not want to worry too much about the choosing right features or right parameters. So for example of this parametric model are linear regression, neural network, logistic regression, and non-parametric model is decision tree, k-nearest neighbor. So the difference is like constant number of parameters independent of training data, and number of parameters grow with the number of training examples. Strong assumptions about the training data means in parametric model we must have prior knowledge of the distribution of data or characteristics of data, while in non-parametric model then simply there is no assumption about the training data. So fewer training samples are required, but these training samples are well curated. In non-parametric model, we need a huge amount of training samples, and these parametric models are comparatively fast, and it will also draw the fast inferences. The same, the non-parametric models are become lazy models, they slow training and slow inferences. So this is also the one way of classifying the model. Similarly for generative and discriminative model. So as it's you here you can see like generative discriminative model like SVM, they have the different type of it. Here we'll draw a hyperplane to classify, like we have the different sort of data are given. So what we'll do, we'll try to draw a discriminative line or discriminative plane for categorizing the data. So in discriminative models, their approach is basically they learn the decision boundary between the different classes, and it will technically it will basically maximize the conditional probability and directly estimate the conditional probability. Cannot generate new data and specifically mean for classification tasks, and discriminative models are not possesses generative properties. Example of logistic regression, random forest, SVM, KN, and decision tree. And this generative model, rather than learning the decision boundary, they will learn the uh, input data distribution, and they will maximize the joint probability rather than conditional probability. And they can generate the new data, and typically they are not used for classification task. Generative model possesses discriminative properties also, and like hidden Markov model, naive Bayes, Gaussian mixture, GMM, Gaussian mixture model, Bayesian network, LDA. These are some examples of generative discriminative model. So these are the classification basic sorry these are the categories how we can classify the model. Okay, so you want to ask something, anybody? Hello.
Is there any question?
No, sir.
Okay. So, so what we so far what we have discussed the basic, means what is machine learning, how we can classify it, and what are the different types of classes with availability of data, whether the models are discriminative or generative, parametric or non-parametric. So how we can classify on the basis of this. But here, how we solve the problem. So suppose we'll take the example of the supervised learning algorithm. So first we have to identify a real problem. The real problem can be of anything, like it can be from the uh, like from healthcare. From healthcare there are many problems, like diagnosis. It can be of diagnosis problem, like uh, by X-ray you want to categorize is whether the subject is suffering from this disease or not. From MRI images, so that's a diagnosis problem. Or from agriculture, whether the plant means what will be the growth of the plant, or what will the yield of the plant, means the plant is suffering from particular disease or not, like this. So the problem can be of anything. So how we can formulate the problem? So first we will formulate the problem, because machine learning, first we have to convert a real problem into machine learning, and then some domain knowledge is required. Suppose you are doing a medical problem, so you should consult with the doctor, means what is the interpretation of this. Or if you are working in health agriculture, then you should consult to the agriculture expert, like what is the meaning of this. Suppose you are dealing with the rice disease, so rice leaves have different colors, so what is the interpretation? If this is slightly yellowish, then what it means? If it is dark yellow, then what it means? If there is some other symptoms, then what is the meaning? So what it means nutshell, the domain knowledge is required. Whatever problem, without domain knowledge, the your results may be misleading. So first formulate the problem in terms of machine learning, involve the domain knowledge, domain experts, and this domain expert and formulation will lead to a raw data. Means, if suppose you have collected the 1,000 samples and consulted with the doctor and label this, so this raw data will be connected, and then we will extract the feature. Expert will tell you that these are the important features which can be used to solve this problem. Like for example, if you are solving some diagnosis problem means you have some x-ray images. So doctors will tell you that if the spot size, suppose on your bone the spot size is larger than this, if there is a crack, then it should like this. So in this way you have to identify the feature and extract the feature, and in this way you will form the feature vector, and doctor will label it. If feature values are this, then this will be your fracture. If feature values are this, not fracture. So in this way we will form the two vectors. One is training vector. Suppose we have extracted n number of features from x-ray image, so this x will be x1 to xan, and then label means whether it is fracture or not fracture. For simplicity we'll assume only this, then it will be a y level. Then we will provide this to the learning algorithm. Learning algorithm will learn out of these 1,000 images, and the next time if will give a unseen image, then your algorithm should be able to give you whether this x-ray is representing a fracture, bone fracture or not, like this. So similarly what we have discussed can be represented in this way. This x can be represented like x1, x2, xn, and this y can be of this, and we can use this training data to train the algorithm, and we prepare the model, and then we can use this model to the. Now suppose we are talking about the image. So what can be the features? Okay, what can be the features? So like the feature can be of anything. Suppose consider these images. So here the raw pixel, here you can see the raw pixel values. Like in image everything is represented by in form of pixels, and the pixel value can be of, in normal images, pixel value can be of 0 to 225, or the depth can be of 256. So a pixel can contain any value between 0 to 255, and the raw means if you don't have any idea, then you can consider the pixel. Then some GIS features, this descriptive global image features are there. Texture analysis feature like statistical, such as first order statistical histograms, second order statistical like GLCM feature, GLRLM feature, structure, local binary pattern feature, model based stochastic, fractal models, transform based wavelet, Fourier Gabor transform. So histogram oriented gradients, Hawk features, co-Hawk features, and pyramid histogram of oriented gradient, p-Hawk features or Har features. So these are the features only related with, means the same problem can be solved by all these methods. We can extract the raw pixel, GIS features, or anything else. Okay, so the problem will depend what type of features we are extracting, and for particular problem, which features are more relevant. Just suppose we are considering the X-ray images, then which type of features we should consider? If you are considering the MRI images, so which type of features we should give priority? So these are the different ways, like directly libraries are available. These GLCM feature, GLRLM feature, set of features are available, and these are known as second order statistical features. We can extract. You can extract the Hawk features, you can extract the Har features from the image, and in this way we can form the feature vector table. So this is a simple how we can do with the help of these features. Now, the different types of algorithms are available. Like we are saying, we are discussing supervised. So there are three algorithm what we have used. Is one is most popularly used is basic algorithm, is k nearest neighbor algorithm. So what is the concept of this k nearest neighbor algorithm? There is saying that tell me your company, I will tell you your nature, or tell me your friend, tell me about your friends, I will tell you who are you. Means like our characteristics are defined by our company or our surroundings. So same sort of concept used in nearest neighbor based algorithm, and KNN is one of this algorithm. Very simple algorithm. Here you can see like this. There are three types of dots are given: red, yellow, and green. Okay, and one unknown, this cross, flower colors. So this cross will belong. So what we'll do, we'll find the nearest neighbor of this cross. So obviously, for to finding the nearest neighbor, we'll measure the distance, and the distance which is more closer, like the those points which has less distance are considered to be more closer. So here you will check that the three red points, one green and one yellow. So, on the basis of this number, because most closures are green, so it KNN will give this unknown data point will be labeled as red. So, different types of distances are used. The key in this KNN is how to find this distance. So if you check in scikit-learn, so you will find a Minkowski distance. So because this Minkowski distance is a general distance formula, and it may lead to the Manhattan, it may lead to the Euclidean distance. And popularly used distances, and even many are known as Euclidean distance. So Euclidean distance is one option. You can use the Manhattan distance, you can use Chebyshev distance, you can use Minkowski distance. So the different here in this diagram, you will see that this Euclidean distance is a direct distance between 2 points. Manhattan distance is like this Manhattan distance is also known as city traveling distance. City traveling distance means we know that we want to go from this point to this point, but directly we cannot go there. So there are paths in city, so we have to follow that way. So such type of distance are known as this Manhattan distance. So Manhattan distance is also known as L1 norm, L2 norm. So here you will check that like xi minus yi is it's a L1 norm, L1 norm, and here this is the L2 norm, absolute distance, and here we are taking the under root, so L2 norm, and here we are taking the infinity, so infinity norm. Next. So here you can see the different colors: blue, green, and what this distance means. Here we should know that which distance will be applicable to where. Like if we are using the, we want to calculate the distance between text, then we use the Hemming distance, not this Manhattan or this distance. So there are different distance formulas are there. The point is that in KNN different types of distance can be used, and uh, on the basis of this distance we will find the similarity. So this is the a brief idea about what is this KNN algorithm. As such, there is no learning, uh, and this KNN is known as parametric learning, non-parametric, because it will no parameter will learn. The training quality will directly depend on the size of the training sample, and you can say this is a you are generative, not discriminative. So, like this, you can attribute it this to KNN like this. The next is the concept of Bayesian learning. So, Bayesian learning, there are two types of things are used in Bayesian learning. One is the prior probability, and another is a likelihood. So here you can check that this in base where there are green and red. So here 40 green balls, 20 red balls, and we want to find out the likelihood of that this white should belong. So obviously number of red in the vicinity and total number of red. So here if we'll simply the prior probability means prior probability more number of greens are there. So this white ball should belong to the green. But if we'll define the vicinity, or if we'll find out the likelihood, means we draw a circle, and in this circle more number of reds are there. So this ball should this white should belongs to the, so this is known as likelihood. Means what we are doing, we are giving one more evidence. So like suppose we are looking at someone, and that on the basis of that just because of he or she has a long hair, we cannot take a decision that means on the basis. Okay. Yeah, you are not able to see this slide. Hello.
Yes, sir. Now it is visible. Earlier, it was only slide 19. I could see.
Here you are able to see it.
No, no, now it is okay.
Okay. So here what I'm saying that like in KNN is work on the basis of principles of calculating the distance, find out the distance, and more closer points are known as its neighbors, and it will decide in this way. In Bayes theorem, what we'll do, we'll take the two things, means it's evidence based. Like suppose if we have seen the long hair, and we cannot conclude that if there is a long hair it means that is a male or female. Okay, we need more evidence, and so if number of evidence will increase, then we will our decision will change. The similar sort of learning is applied in base. Like here initially 40 green ball and 20 red ball. If unknown ball, then number of greens are more, so the prior probability that this ball will belong to the green. But we will define the vicinity. Vicinity means it will draw the circle, and if in this circle more reds are there, then according to likelihood this ball will belongs to should belongs to the red. So prior probabilities indicate that X may belongs to the green. Likelihood indicate that X may belongs to the red. So in Bayesian analysis, the final classification is produced by combining the both source of information. And what are the both source of information? Your prior probability as well as likelihood, to form the posterior probability of this unknown data point X using the Bayes rule. So we can calculate like the posterior probability of green, posterior probability of red, and finally we classify this X as a red since it's posterior. If we'll calculate like prior probability of green into likelihood of green, prior probability of red into likelihood of red. So if numerically we will calculate, then it will X will belongs to red. And this is the formula, this is the algorithm how we can use. So here you can see like this PXC, the conditional probability, which is known as likelihood, where X is our input vector and C is our class, and this is the class probability, and this the predictor prior probability, and we have to calculate PCX, means agar x, if x is given, then it should belongs to which class. So P Cx is the posterior probability of class given the predictor or attribute or features. So first we'll calculate the prior probabilities, compute the probability of each class in the training data, calculate the likelihood for each class, compute the probability of observing the feature given the class, and then apply the Bayes theorem. This is our Bayes theorem. And this classifier is known as naive-Bayes classifier. Why naive-Bayes classifier? Because here what we are assuming that each feature is independent of others. Means feature independence is assumed in this class, but it is not necessary that all the time features are independent. So if there are features are not independent, then this classifier may not work well. So this assumption itself is a very naive in nature. That's why this classifier is known as naive-Bayes classifier. Bayes is theorem. This theorem is known as Bayes theorem, and naive is just because of its assumption, which is very basic, and that's why this is known. Similarly, algorithm which is known as decision tree algorithm. So what decision tree algorithm? Suppose this data set is given. So this data set may lead to some decision rules. So now this data set, if we apply the decision tree on this data set, then it may lead to this decision tree. So here what we are doing, we are converting this table, like this is a toy data set. Right? You may have encountered this data set in many data mining and machine learning books and tutorials. So what is this data set? Only 4 features are there, like age, income, student, and credit rating, and a class level by computer. Means if someone is youth, high income, but not a student, credit rating is fair, then class by computer means no. If someone is youth, income is high, student no, credit rating is excellent, then middle age, income high, student no, and credit rating is fair, then by computer decision will be yes. So similarly, this table can be used to train a decision tree classifier, and it will produce this sort of decision. So if we'll convert into set of rules, then student no, income high, age less than 30, then by computer decision is no. So what we can do, we can test the other. So what is the gist here? Here you will check that 4 attributes are there: age, income, student, credit rating. And here you will check that the root node is selected. So here first we have to split the information. So why this student is selected as a root node, not the income, not the age, not the credit rating? So for this we have to calculate the entropy. Entropy is the measure of uncertainty. Means if suppose which column has most entropy in this table? Anyone?
Sir, table is not visible, sir.
Now it's visible.
Yes, sir.
So can you tell me which column has the maximum entropy? The whole table, considering this RID also, and why? Anybody? Because this is also, decision tree is also a very fundamental algorithm, and in many many boosting algorithms, the decision tree is used as a base learner. So here you will see that what I am saying, the entropy is the measure of uncertainty. So here you will check this, if we'll consider this RID as a attribute. So you will find that every value is unique. Okay, every value is unique. And if all values like class, all levels are yes, then there is no uncertainty. If some are yes, some are no, then if 50% are yes, 50% are no. So like if we coin the toss, then outcome is, it can be of 50% head, the chances of head is 50%, chances of tail is also 50%. So in that case, our uncertainty, element of uncertainty is maximum. So entropy is basically the measure of uncertainty. And so what we'll do in decision tree, first job is to measure the entropy of each and every column, and the maximum entropy column will be converted into root node. And then again we'll perform the same thing, and once we'll get the all attributes, all values are homogeneous, then we'll stop it. So different types of attribute measures are used, like in ID3 algorithm. As I said, that decision tree is basically a family of algorithms. Many algorithms are possible, like CART, ID3, C4.5, C.5, J48. This J48 is nothing but the Java implementation of C4.5, and in Weka it is used. This decision tree is used as a J48. So in ID3, the measure of entropy is the information gain. Okay, so measure of information is information gain, while in C4.5 algorithm, the measure of entropy is gain ratio. So gain ratio is a more improved version or more correct way of measuring the uncertainty. So here we will use, that's why the C4.5 is more popular. And while in CART, the Gini index is used. The Gini index is also a statistical measure, very old. So on the basis of, we can apply any of the measure. Because this information gain is now nobody is used, because it's a superior form is this gain ratio. So we can apply this gain ratio and calculate the uncertainty of each and every column. So this is the how decision tree will algorithm will work. And similarly, the one more algorithm, I will skip it, it's SVM. As we are saying that in SVM, what the SVM is a discriminative. Discriminative means what we'll do, we'll draw a hyperplane, or you can say the separating hyperplane, separating maximal marginal hyperplane. There may be it's optimal separating hyperplane, because hyperplane can be of anything. So hyperplane, it can be of line, it can be of a two-dimensional hyperplane, it can be of three-dimensional. It will depend on the data, what dimension data we are dealing. Suppose we are dealing a two-dimensional data, then hyperplane will be a line. If we are dealing a three-dimensional data, then hyperplane will be a surface, two-dimensional surface, like this. So here, and we'll convert this problem. We'll find this support vectors, and this problem can be converted into optimization problem, and we'll maximize the hyperplane. So this again, this minimize or maximize this. So again, this SVM can be of you can the primal, and you can the dual, where we'll use the kernel tricks. So here, why we use this kernel tricks? Because the data is not linear all the time. The data may not be linear all the time, and if data is like this, then we have to transform the data. We have to change the nature of data. And how we will apply some mathematical function which is known as kernel function, and this kernel function will project this data into some high dimensional space where we can insert some separating hyperplane. So this is a kernel trick. So without discussing much, the different types of kernel functions are available, like spherical, wavelet, Bayesian, Cauchy. There are many. Okay, and different types of the kernels are available. Like if we are using this uh, so it can be of linear kernel, it can be of polynomial kernel, Gaussian kernel, so sigmoidal kernel. So by using, so SVM means this SVM with kernel tricks, or otherwise this hard margin SVM means primal SVM. There are two forms. Hard margin means that there are no possibility of misclassification and limited use. Soft margin, yes, we can means we have some appetite for errors, so it can adjust misclassification rate. And but this primal form is applicable only for linearly separable problem. Linearly separable problem means straightforward, we can draw a line. But here you can see such type of data, we cannot draw the line. So what we'll do, we'll use kernel tricks, and kernel trick is, it's a magic, okay, mathematical magic, not magic. So what we'll do, we'll transform or project this data into some higher dimensional space, and where we can perform the dot product among the vectors. So this is a very good technique. This is used by these SVM machines. So these are things like some basic algorithm I just discussed, like KNN, decision tree, or naive Bayes, and this SVM. So KNN, mainly distances are used. We have to store the whole training data set. In naive Bayes, we use the concept of prior probability and likelihood. In decision tree, we use the concept of entropy to decide the root node. And in kernel, we use the kernel tree. Sorry, in SVM, we use the kernel tricks for projection. So this performance of these models can be measured by the confusion matrix. This confusion matrix is means like how we'll decide which. Yeah. Anybody wants to ask question, please. Now you are able to see this slide because we are moving in next section.
Sir, will you be discussing about fuzzy C-means clustering, sir?
Okay, I will not discuss fuzzy C-mean clustering, but because you asked, so I will give you a brief idea of fuzzy C-mean.
Okay.
Okay.
Sir. Okay,
So yeah. Means like you may be aware about the k-mean clustering.
Yes, sir. Yes,
So
sir.
yes, in k-mean clustering, the cluster, the whatever cluster we form is a hard cluster. Hard cluster means if suppose some point will belongs to cluster one, then it will always belongs to cluster one. Okay, like this. So
Yes.
membership function value will contain a binary. Means a point belongs to C1. If the membership value will always either if belongs to C1, then the membership value will be 1. Otherwise 0. 0 means it will not belongs to C1. It may belongs to C2, C3, C4, or for that matter, not any one of them. But in fuzzy clustering, there are many situations, the real-time situations where a data point can belongs to multiple like I'll give an example. Like suppose the many faculties are working as a PhD scholar in some institute and full-time faculty member in some other institute. Okay, so their affiliation is belongs to both institute. They are for suppose for X institute they are affiliated as a scholar, and Y institute they are affiliated with as a faculty member. So their role is important at both places. So the concept of fuzzy C-mean, there are situations where the point may belongs to more than one cluster with different membership values. Say this point is belongs to cluster 1 with zero point 0.6 and with cluster 2 with 0.4. Means the point is relevant to both the cluster in context, but their membership value is different, like 0.6, 0.4, 0.3, 0.7, or 0.5, 0.5, like this. So this concept is known as fuzzy clustering, where the members may the cluster members or data points belongs to the cluster may belongs to more than one cluster with different association, different membership values. This is the
Okay,
concept of fuzzy C.
thank you.
Technically, it is like what objective function we will use for k-mean clustering. That objective function is modified in C-mean fuzzy C-mean clustering or fuzzy C-mean clustering, like this. Okay, anything else?
Thank you, sir.
So, so far what we have discussed, we have just discussed the basic algorithms, means what is machine learning overview and what are the basic fundamental algorithms and their core principles only. Like in decision tree, the important thing is only how to measure the entropy of a tree. This is the key point. And in naive Bayes, how to find out the likelihood and prior probability. In SVM, means how to perform the projection or to design the optimization function. Now, the next thing is how to measure the performance of. Now, this slide is visible. Yes, confusion matrix. Hello.
Yes, sir.
Okay. So,
Yes, sir, visible.
yes. So here means what is our objective? Just suppose we have learned these four models, four supervised algorithms. The same algorithm can be used for regression also. Like in scikit-learn, we use the SVM, SVC. It's a defined as their SVC, and for regression it is used as SVR. Okay, so if we are using SVR dot something, then it is for regression. for classification. So what is the difference between regression and classification? Simple. If labels are available in discrete values like 5, 6, 8, 10, 50, so then this problem is classification. If labels may contain the real values, like it can be of anything, 1, 1.1, 1.2, 1.112, then such type of problem is known as regression problem. Okay, so yes, any model can be used for classification as well as regression, whatever we have discussed. So now the next question is how to measure the performance. And to measuring the performance, we use a data structure which is known as confusion matrix. This confusion matrix is a 4x4 matrix for binary classification problem. For class 3 problem, it can be, for 3 class problem, it can be a different for close. For the measure is 2 by 2 matrix, and what it contains means what can be our output of any classifier. Means we have some actual values and we have some predicted values. So actual value means if actual value is 1 and predicted is also 1, then it's okay. Actual value is 1 and predicted is 0, then it's not means not correct. If actual value is 0 and predicted is 1, then this is also not acceptable. If actual is 0 and predicted is 0, then it is okay. So means on the basis of this notion, the 4 types of values are used. True positive means if actual value is positive and predicted is also positive, then we'll say the true positive. If actual is negative and predicted is also negative, then we'll say it's a true negative. Actual is positive, actual is negative and predicted is positive, means what we are, our model is doing the false positive. So this is known as false positive, and these false positives are defined as type 1 error. And if actual value is positive and your model is predicting it as a negative, then this is known as false negative, and this type of error is known as type 2 error. And there is always a debate between, means obviously type 1 FP and FN are not acceptable. Means what we should do, we should minimize the number of FP and number of FN, and we should increase to TP and FPN. So obviously this FP and FN are not desirable. So these are designated as a type 1 and type 2 error. Now the question is, which one is more dangerous, type 1 or type 2? So the answer of this question will depend on the problem, what we are doing. So whether we can afford the false positive, number of false positive, or the false positive is like if suppose you are you don't have any disease and your model will predict yes you have a disease. If suppose we have designed a model for predicting a cancer, for the example cancer, and if someone has someone do not have cancer, means our cancer is a positive class here, but our model is predicting the positive. So means what, this type 1 error is more dangerous or type 2 error is more dangerous? So it will depend on the problem what we are doing. So on the basis of this this will be the confusion metric, like actual class. And don't try to remember this, okay? This logically you have to drive like actual is positive and predicted is positive, both positive, then true positive. Actual is positive, predicted is negative, then it's a false negative. If actual is negative, predicted is positive, then false positive. Actual is negative and predicted is negative, and true negative. So on the basis of these 4 elements of the confusion matrix, TP, FP, TN, FN, we can derive the different types of measure, like precision. So precision is ball, how many number of true positive out of the total predicted positive. So TP upon TP plus FP. Similarly, this recall. So how many actual positives with respect to the total number of positives. So TP upon TP plus FN. This recall is also known as sensitivity. Precision is known as PPV, positive predicted values. This true TPR, this is also, this sensitivity is known as recall, as well as sensitivity, as well as TPR, true positive rate. And we can find out the specificity. Specificity means total number of negative divided by total number of negative plus total number of positive. And obviously accuracy is TP plus TN divided by TP plus FN plus FP plus TN. So we can derive the different number of measures by just remembering this 2 cross 2 matrix, not remembering, just drawing these two cross two matrix. So this is the how we can measure, means how model will measure the performance, how will measure the performance of any model. So like this is stock crash prediction. So imagine a situation where our model has wrongly predicted that the market will not crash and instead it crashed. The people have go through the lot of losses in this case. So the measure which takes into account this problem is recall. So we need to focus on reducing the value of Fn and increase the value of recall. Okay. How it will increase the, because it will reduce the Fn, then what is recall? TP upon TP plus Fn. So TP is same. So if you reduce the Fn, then your denominator will decrease, then your over value recall will increase. In most medical cases, such as cancer prediction or any disease prediction, we try to reduce the value of Fn. So example like spam detection. So in case of email spam detection, if email is predicted as spam, sorry, it's written as a scam, but it is not actually spam, then it can cause a problem to the user. For example, suppose you are getting an email and your model is too hard. Too hard means for any this mail is related with your appointment letter or appointment offer or some interview call. Okay, and just because of that sender is not in your whitelist. Hello,
Sir, slide is not moving.
not visible.
Slide is not moving actually.
It's visible.
This is visible but not moving. This is not coming one by one. Actually, this is just fixed. In
Sir, you are
confusion
still
matrix.
on the confusion matrix page.
Okay. Now,
Now still not moving, sir.
okay.
Yes, sir. Moving, sir. Currently moving, sir.
Okay. So please let me check. Like now you are able to see the 34. Hello. 34.
Yes, sir. Yes, sir.
Okay. So what we are discussing, suppose I am giving an example. Suppose we are talking about the spam detection or spam filter, and you are supposed to get a important call letter or some important email, and your spam detector is too much strict, and that email may be diverted to your spam folder. So you may not be able to check it, and that opportunity may be missed.
Page
Okay.
number 33, I suppose. Precision or recall.
Yes. I am discussing that only. So means the here if rather than sending that email, if that just because to receive such type of important mail, if some spam email will also receive your main mail, then there will be no harm. We can, because every day we'll receive such type of email. That's why if spam filters are there, then why we are receiving this mail? Because our spam filters are not too restricted. Otherwise, there is a possibility that we may miss the some important email. So that's why if yes, we will receive some spam email, then we can send it manually to the spam folder. So we have to focus on, means in this case we need to focus on reducing the value of false positive when the mail is falsely predicted as spam, and the result increasing the value of precision. So here what it means that like precision and recall. So if we want to increase the precision, then recall will decrease. If you want to increase the recall, then precision may decrease. So there is a trade-off between precision and recall, and it will depend on what type of problem we are solving. If suppose like in case of COVID, so there was two types of tests. One was the screening. So screening was the many people will fail in the screening, and then at second stage they will be tested and no COVID. But yes, their recall value should be high, because nobody should left. But because otherwise, because that was the contagious disease spreading very fast. So the keeping recall value high is nothing harmful at that time. Okay, in second stage, automatically it may be if not case of COVID, if false positive is too much, then we can do it. Okay, so here we have to keep in mind where we have to high precision, we have to keep recall high like this. Sometimes we means for many problems we have to focus on both precision as well as recall. So how we can combine these two measures? So we'll use a new measure which is known as F value. So or this is also known as F1 score. Now this slide 34 is visible. Hello.
No, sir, we are still on 33, not on 34.
I don't know why this is happening. So what I will
Yeah,
do
yeah. Now it's
actually,
now it's a
I
come.
will click it
Now it is
from.
there.
But every time it is not possible to. Now it's 34 is visible.
Yes, sir, 34 is visible.
Yeah, you can see the content of 34. So I will keep it into this mode only. So it will be convenient for me. It's 35.
Yes, sir, 35.
Hello.
Yes, sir, yes, there is
Okay.
35.
Okay. So, okay. But sometimes we are interested in both precision as well as recall. So what we'll do, this AF measure will combine both precision and recall. And this AF measure is nothing but the harmonic mean of precision and recall. Harmonic mean. Okay. Harmonic mean, not algebraic mean. So why we are taking the harmonic mean of precision and recall? Because if we'll not take the harmonic mean and we'll take some other mean, then the higher values, like if precision is high, then the high value of precision will reflected in your F1. While F1 is designed to measure or to consider both or to give equal importance to both precision and recalls. That's why we consider the harmonic measure. Harmonic measure. So the higher value of any of the uh, value of precision or recall may not dominate the F1. Okay, so this is also this F1 measure is nothing but the harmonic mean of precision and recall. Similarly, we use this sensitivity and specificity. So sensitivity is nothing like is the sensitivity is same like this your true positive rate, or we can say the recall rate. Specificity also called the true negative rate. So true negative rate is known as specificity, and false positive rate is 1 minus specificity. So these are some measures popularly used by to measure the performance of your classifiers. One more measure which is known as ROC, receiver operating curve, or AUC under ROC, area under curve, receiver operating curve. So here, what we'll do, we'll define the threshold. Here you can see that like TP, FP, TN, FP, and TPR, FPR, and on the basis of this, ROC is basically TPR versus FPR. And for every value, we'll plot these values, and ideally this curve should be look okay, curve should be look like this. C1 is one classifier, C2 is another classifier, and the area covered by C1 is higher than the area covered by C2. So obviously C1 is better than C2. So ideally is like it should be go to the up and then down. So we can plot by applying the different threshold. So this AUC ROC measure is also extensively used to measure the classification. Yes. Any question? Hello. Hello.
Is there any question, please? Bharti Sahu, you have raised the hand, please. Sir, what about spider web? Spider web.
Spider curve. Where is spider curve? Hello. Yes, Ravi Bhushan Dixit. Means what about the spider curve? Means where this spider curve? Yeah, I don't know. Means there may be the different literatures are available, and I don't know what is this spider curve and which context you are asking. Uh, it is not relevant, but I want to know about. I don't have any idea about this spider curve. Okay, maybe something. If you want to ask whatever we are discussing in this context, you want to ask, then please ask. There are so many things. Maybe means. It is not necessary that we are aware about each and everything, but if you would like to ask from this only, then please ask.
Padma also have asked whether it is essential to calculate all the performance metrics listed you to be calculated for any classification problem.
Okay, not
Yeah.
necessary. Yes, Padma Usha, not necessary. All are not necessary. But yes, we cannot rely blindly on accuracy. Like accuracy is misleading. If suppose you have instances of more instances of one class, then your accuracy will be biased to that class. So if your class is not properly balanced, class balance means suppose you have two classes and instances of one classes are 90 and other classes are only 10, and then 90% of the time your classifier will be even doing the misclassification, it will be correct. So yes, not always all necessary, but many times your single performance evaluation measure will not serve the purpose, and we have to test it from other angle also. Like sometimes accuracy may not be sufficient, accuracy is misleading, so we have to calculation precision, we have to calculate recall. So we have to means what is our problem? Our focus is precision or our focus is recall. It will depend on, like we have discussed the cases. Suppose you have installed a surveillance system. Surveillance system means to check the suspicious person. Okay, and if suppose you identified some suspicious activity of anybody, and you want to do the frisking more carefully, or frequently we see at airport that some persons were checked more thoroughly than the other. So if suppose here recall is important, means no case should be missed. If suppose some mistakenly anyone can be considered and it can be frisked again, then it's okay. But if suspicious person will uh, left from the system, then it may be more dangerous. So such type of problem, recall is more important than precision. Okay, so like we have discussed the one case of this COVID, so recall value is more important. So it is not necessary that all the time we have to calculate all the values, but yes, more than one measure is always advisable. Yes. Okay. So now we to move further. So we'll discuss a one case quickly. And as we know that different types of medical imaging modalities are used. Imaging modalities means capture the images of body part, like radiology, so like x-rays, this computer tomography, CT images, CT scans जिसको बोलते हैं हम, ultrasound, USG, MRI, okay, SPEC, PET. These are more advanced tests. So different types of tests. Why we this diagnosis test we conducted, just to detect the different types of disease. Similarly, the visible light imaging, microscopic imaging, multimodal imaging. So these are the different medical imaging techniques used to capture or to diagnose the different types of disease. So you may be heard about most of the technology. Here our objective is to consider a case. So the here we want to here you can see that the images, and you may be able to infer that these images are our brain segments basically. So MRI images. So three different head MRI scans are shown in the images. and these images are unprocessed, means same image, same data, different visualization with different contrast. So however they different in the way on grayscale they are visualized. So medical imaging like MRI, CT scan, X-ray, all are required imaging equipment, and these imaging equipment are substantially different from our camera. Means like if suppose we want to we cannot take a photo of any tissue, specialized equipments are required for that, and specialized softwares used by the medical practitioners to interpret those images. So one major difference is that the gray values are measured on different scale. So one in MRI, the voxel means the voxel intensity depends on the receiver gain of MR, which machine which used to take the MRI, which is again may be impacted by many factors like the magnetic field strength, machine kiski hai, vendor type, the pulse sequence, but can be range from 0 to multiple thousands, while the gray scale images are captured in 0 to 2. So having this large number of intensity values, it may pose some challenges. Neither our eyes nor computer allows for appropriate the differentiation in such great detail. So specialized medical equipments, or we can say the medical softwares or medical imaging standards, are used to see the such type of images. So computer has a fixed depth of 0 to 55 or 256. So instead of just squeezing 10,000 values of medical images into this 256 buckets, we can adjust the windowing. So what this windowing allow us to set a level and window width for those gray values that we want to visualize. So values outside this range are either black or white. Like here you can see this in this example, the histogram represents a histogram of our brain, where the peaks roughly correspond to the cerebrospinal fluid CSF, and gray matter and white matter. So with this window level setting, this CSF will visualize as a solid black color. Let's see the bottom, and tissues within the window will visualize on grayscale. So where the matter is brighter than gray matter, CSF will be dark. So we'll define the means window level define the range of intensity visualized on grayscale. This allow focus on a specific tissue contrast. So for example, if we are interested in soft tissue such as gray and white matter, we choose a window level optimizing the contrast between them. If we want to see the background noise, we try to focus on intensity values representing background noise and optimize the parameter for them. So having this flexibility in visualization allow the radiologist to play around with windowing setting and optimize the image for particular reason they are looking for. So there is not only the window level setting used for the analysis, rather it is also wide range. So window level for only visualizing higher intensity motion artifacts become visible, and good contrast between white and gray matter. So here you can see this MRI brain scan with 3D slicer. So therefore, specialized medical imaging software allows one to easily adjust the window level for the base contrast, often done by moving the pass cursor into different directions. So some open source software are also available for visualizing the medical imaging like DICOM and Nifty file format, or ITK Snap, FSL license, 3D slicer, image, etc. So right click, open up the menu with the right button, pass, and window can be adjusted. So the windowing of image is very important. Here, what is this Alzheimer basically? So Alzheimer is a neurodegenerative disorder, and which may affect our personality, our cognitive ability, emotion, and memory by causing the structural change in our brain. So there is currently no cure. However, we up to certain extent we can prevent if we know in advance that it's a type of dementia, like so we can reduce the risk. So the challenge is like this Alzheimer is progress very fast, and there are different stages of this disease. So what we can do, if we know, I mean, by any technique, if we know in advance, then um, we can stop its progress, or we can minimize its progression as fast. So if we'll detect it early stage, then only we can do this. So the detection of Alzheimer is very important, and for that matter, we can use the different, like from brain MRI, we can apply machine learning, deep learning algorithms to uh, detect which stage this disease is affecting. So the effect, what is the effect of this Alzheimer? Our brain will shrink, and the hippocampal size decreases, and the brain ventricles expand as a result of Alzheimer's disease. Memory, reasoning capacity, and the person's gesture to issue in day-to-day activities all deteriorate as Alzheimer's disease progresses. So, understanding Alzheimer's disease, mild cognitive impairment and cognitive impairment, normal manifestation, has been one of the neurologist's most difficult tasks in recent years. So different stages like Alzheimer, dementia, mild cognitive impairment, late mild cognitive impairment, early mild, means these, you can say these are the different stages, or we can consider them as a different classes for classification. Like for MRI images, we can uh, we can classify that at what stage patient is. Different data sets are used, and one data set is ADNI data set is very popular. So Alzheimer disorder using MRIs, so the texture, structure, volume of the brain are used to distinguish healthy brain from the diseased brain. So MRI is valuable imaging modality used in the evaluation and diagnosis of Alzheimer, because it can provide the structural information about the brain, allowing clinician to detect changes. So there are different types of, again, there are different types of brain MRIs, like structural MRI, functional MRI, diffusion tensor imaging, or amyloid imaging, longitudinal monitoring, early detection, and differentiable. So these different types of images can be used for either longitudinal monitoring, tracking the disease progression, like serial MRI scan, 1 month, second month, third month, like this. So serial MRIs can perform over the time, can be used to track the disease progression. Like if 1 month, this is the status, mild cognitive. So next month, how, whether this is progressing or not progressing, allowing clinician to assess how the different disease affect the brain structure and function. Or the other is early detection and differential diagnosis. MRI can assist in early detection of Alzheimer's disease and help in different forms of the So what we can do, if we know as early as possible, then we can stop the further new neurodegenerative disorders. They may present with similar symptoms. So here we'll consider the structural MRI input data view. Here you can see the axial view. Axial view means a view of the brain from the top to bottom. Coronal view, view of the brain from front to back of the brain, and sagittal view, view of the brain from side to side. So here you can see these three types of MRI images. Now, as I was this given the brief description of data set, like we have collected this data from ADNI data set. So this cognition stage is CN, significant memory concern, early mild cognitive impairment, late mild cognitive impairment, mild cognitive impairment, or Alzheimer dementia. So here you will see the number of patients, like male patients and female patients, number of male patient and female patient, and their average age. So with these images, different types of pre-processing we have to perform MRI image processing, and one is resampling. What is the process of altering the spatial resolution, size, or orientation of the MRI image or volume is known as the resampling. While do the rim sampling to improve the image quality and matching the MRI data to specific reference frame, or the making the data compatible with the because I already said that these images are not read by the human uh, some specialized softwares or techniques, some costly softwares, specialized softwares are required to read the images. So this sampling is mandatory. Yeah, and then N for bias correction. So this N for bias correction is used to correct the intensity inhomogeneities or special variations in the image intensity that can occur due to magnetic field or other factors during the MRI acquisition process. So means different vendors supply the different machine. There is a possibility of this inhomogeneities or special variations in the images. So this possibility of means it may lead to N4 bias correction, and this N4 bias correction is basically the order of the correction polynomial used, and which is the fourth order correction, a fourth order polynomial. So the MRI scanners may produce images with intensity variations across the image due to variations in the magnetic field, coil sensitivity, or other factors. And these variations appear as a smoothly varying background signal, often referred to as the bias field. So they impact in intensity homogeneities and can obscure important anatomical structures, affect the accuracy of image analysis algorithm, and hinder the interpretation of the MRI data. So this here you can see the MRI image processing or N4 bias correction. One more technique is scalp stripping. So this is the process of segmenting the brain tissues from the surrounding non-brain tissues, such as the scalp, the other extraneous structure in the brain. Why this is necessary, crucial, because it allows researchers and clinicians to focus on the brain structure for the further analysis, such as volumetric measurement, lesion detection, and region of ROI or region of interest analysis. And the next pre-processing step is image registration. So image registration is also a crucial step in Alzheimer's disease diagnosis, and this involves aligning a spatial mapping of multiple MRI images from same patient or across the different subjects. Why this registration is essential? Because comparing brain structure over the time across individuals or across different imaging modalities, and this allow the tracking of disease progression, assessing the different treatment efficacy, and comparing brain structure between the healthy and affected subjects. So there are different techniques for image registrations are used, like linear registration, non-linear registration, and diffeomorphic registration. So the details are available of these techniques. So here you can see like these are the different uh, uh, different brain images before registration, and after registration you can see in the second uh, pane the different, you can see the uniformity in the images. So we can use yes, these are the image pre-processing code which is used to pre-process the different images. This Nimbeable library, which is you can say the this Python library is available to read the different image formats. And now we'll perform the, after doing registration, perform the MRI image segmentation. So accurate segmentation is used for quantification of specific brain regions such as hippocampus and cortical structure. This is crucial for understanding the disease progression and risk. Feature extraction, uh, first we'll perform the MRI segmentation and quantifying the specific brain regions, extracting the meaningful information from the analysis. So this VBM voxel based morphometry, this VBM allows the comparison of brain anatomy, including the volume, shape between the different groups of individuals, such as algebraic patient and healthy controls. It also involves the processing of MRI data to align the brain in common space, then analyzing different in voxels, intensity or volume between the groups. We'll also perform the region of interest analysis. So ROI analysis involves manual or semi-automatically defining the specific brain regions that are known to be affected by the Alzheimer disease. And the example, hippocampus or amygdala. So MRI data is then segmented to measure the volume and other characteristics of region, which can be used to assess the progression of the disease or the effects of treatment. So here you can see like the registered images now will apply the segmentation, different segmentation technique, and here the same brain images are segmented into different regions, and on the basis of this segmentation we use stage by segmented result, like this is the case of cognitive normal and mild cognitive, early mild cognitive, late mild cognitive, or AD. So here you can see these are the original images and these are the respective segmented images. Means the same images after segmentation they will look like this. Now how will perform? Obviously these Python libraries are available to segment these images. So we'll pass these images as input and it will give this result. So here like so the segmented MRI images are considered input in feature extraction stage. So two techniques are used for MRI image feature extraction. So first what we'll do, we'll perform the pre-processing, then registration, then segmentation, and now we'll apply the feature extraction. So the features, what type of features we are extracting? We are extracting the Hawk features and Har features. Hawk features and Har features. So here you can see like this volume, right hippocampus, left area, thickness, shape, cognitive assessment, live neurons, demographic information. So different types of features here, different types of features. Hello.
Hello. Sir,
Yes.
time is over, sir. Kindly, if you conclude within 5 minutes, better, sir.
Okay.
Because next session is going to be started.
Yeah.
Okay, sir. Thank you, sir.
So what we are doing, the different types of regions with extracted features here, like the Hawk features captures the local gradient information in image, particularly used for detecting, describing object shape and textures. So again, different ways of like gradient computation, gradient histograms, block normalization, feature vectors. So Har features like simple rectangular filter based features that are often used object detection tasks, including fake detection images. So we can the integral image, Har like features, feature calculation, feature vector. So different features will compute it, and it will lead to like where is yeah. So this number of features we have, these like left hippocampus. So number of features we have calculated 144, right hippocampus 63, left 134, and number of features like volume features and shape features from each and every region. We have calculated this much number of features, and we'll create a feature labeling, feature vector, and we'll give the label to these features like here you can see in the code, because ultimately it is not done manually. Volumetric features, volume of segmented brain shape features, measure of the shape of the structure, and we'll use these features to train the different models. Like whatever model we have discussed, we are training the same models. Okay, so these 4 models we have discussed, we are training these 4 models, and the other choices are also available. We can perform the experiment this also, but this will perform the training with these 4 models. And here you can see Means what we are doing, we are taking this data set will be divided into training 70%, validation 15%, and test set 15%. So, and we'll perform cross validation, k-fold cross validation, or we can say the 10-fold cross validation. Here you can see this, and these are the results. What we are doing, we are computing with these four models. What we are doing, we are computing precision recall F1, and different stages are uh, for different stages. Here you can see, and this evaluation through confusion metrics like CN versus AD, CN versus SMC, CN versus EMCI. Here also the remaining because what we are doing, one versus all, we are merging with all other classes into one, and these are our results. You see curves for different categories. So result of ML models may be assistive or may assist to doctors up to some extent, and this for because these images, deep learning models are more means produce more accurate result, or in future we can use deep learning model with, because deep learning models are black box in nature, so we can use the explainable AI model along with the deep learning model to explain the results. And these are the some published papers from this work, 3-4 papers already published. These are the references. So okay, yeah, it's over from my side. If anybody wants to ask question.
Yes, any question, please? Any question? Okay. So thank you, sir, for enlightening your lecture in ML in Alzheimer detection using MRI images. Your discussion on using machine learning to detect Alzheimer through MRI images was particularly insightful. You explained how AI analyzes neurological data to identify early signs of the disease, crucial for timely intervention. Additionally, you covered the basics of machine learning, discussing fundamental algorithms and how decision tree depth impacts model accuracy. Your detailed examination of MRI technology and its integration with AI to enhance diagnostic capabilities for Alzheimer's was invaluable. Your presentation not only highlighted advanced AI application, but also encouraged us to consider how these technology can be implemented effectively in our healthcare projects. The insights you shared have significantly enhanced our understanding of AI potential in healthcare diagnostics. We appreciate your expertise, the knowledge you share, which has deeply enriched our learning and inspired us to integrate this advanced strategy into our initiatives. Thank you once again for a truly informative and inspiring session. Your contributions to our understanding of AI in healthcare are deeply valued, sir. Thank you so much, sir.
Thank you very much. And I would like to give an answer whether pre-processing or contrast sequence process will affect the actual existence of hormone. No. This the objective of this technique is to improve the image quality. Okay, only image quality, and anyway they will not affect the existence of abnormalities within the images.
So session 10 minutes, there is a tea break, and after 10 minutes
So
we will join.
thank you.
But you kindly, you all people join. Don't leave it. Okay, thank you.
Thank you very much. So may I leave now?
Yes, yes, sir. Thank you, sir.
Okay.
Thank you so
Thank
much.
you very much. Thank you, everybody.
We'll have break for 10 minutes and we will join by 4:25. Okay.
Yes, sir.
Thank you. Session is going to be start by 4:25. Thank you so much.
Thank you, sir.
पूछ लो कल कितना बजे है।
So, good afternoon to all, and welcome back after the tea break. I'm Dr. Ujjwal Vishwas, co-coordinator of this STC program. Now I am happy to introduce respected Sir Dr. Sandeep Raj for his talk. He is currently serving as an assistant professor with the Department of Electronics and Communication Engineering, Indian Institute of Information Technology, Bhagalpur, Sabur Vihar, India, since 2018. He received DST Square Fellowship for pursuing the PhD degree in Electrical Engineering from IIT Patna, Bihar, India, 2018. He has published more than 25 research papers and also submitted 2 patents. Welcome to you, sir. Now I'm handed you over to for your valuable talk, sir.
Thank you for the introduction, sir. Am I audible?
Yes, yes, sir.
So first of all, thank you to the organizers, the coordinator, Dr. Dilip Kumar Chaudhary, sir, and Ujjwal Vishwas, sir, and Ravi Kumar Mehta, sir, for giving me an opportunity for this lecture. The topic of today's lecture is applications of artificial intelligence and IoT in agriculture. So the objective of this lecture, what we are going to find is we will have the brief discussion on what is artificial intelligence, its application in the domain of agriculture, as well as IoT. And finally, we will try to develop a complete solution in a form of software, or we will see how we can implement the different AI algorithms on hardware for a development of a complete end-to-end solution, so that the farmers or the related uh, humans can be benefited of the today's advancement in the technology. So the basic idea behind AI is we want to make the machines capable to think like humans. It is also known as machine intelligence, and it is a domain of computer science, and it is defined as the study of intelligent agents as any device that perceives any information from its environment and takes action that minimizes its chance of successfully achieving its goal. AI is applied in learning and problem solving, and we will now find that AI is now part of our daily life, whether we know it or not, whether we accept it or not. Everything that we do, like buying clothes, shoes on the internet, as well as on watching TVs, shows on TVs, is influenced to various extents of AI. So the term artificial intelligence is used to describe machines that mimic cognitive functions like humans associate with human minds, such as learning and problem solving. So the basic aim of the implementation or the study of AI is to develop intelligent computer systems. We want either it can be the complete solution can be in the form of a software or a device, and that should be capable of taking decisions like humans. AI works, but it involves the basic idea before the application of AI involves large amount of data with fast iterative processing and intelligent algorithms, allowing the software to learn automatically from patterns on features in the data. So broadly, AI is classified into three uh, classifications. It has three classifications. The first one is weak AI, strong AI, and the super intelligence. The typical, you may be all knowing, so just first few slides, I am just highlighting a brief about what is AI and IoT and what will be its applications. That just it will take just 5 to 10 minutes to just give you a brief up what different applications we can have. So we are currently in the domain of strong AI, what I believe is because we want to just develop machines to be capable of taking decisions like humans. And the typical examples in case of weak AI are you can think of Google Assistant, Google Translate, Siri, Cortana, and Alexa. They are all machine intelligence that use NLP. And in the case of super intelligence, intelligence far surpassing that are of brightness and more gifted human beings. Due to recursive self-improvement, super is expected to rapid outcome of creating artificial general intelligence. So basically, in the case of super intelligence, we can have the capability of machines to behave or taking decision beyond the capability of humans. So this is still superficial for till date, but it is or it may be possible in the next 5 to 10 years. So what are the basic expectations from AI? So studying, making projects, publishing papers, having degree is fine. But the main aim in day-to-day practical life that should be to develop a complete end-to-end product. Either it can be a form of a software and its typical applications can be, the solution can be developed in the form of Android application, or it can be a web-based solution, or it can be a standalone software like uh, Microsoft Office, or we can also develop a device using some microcontroller platforms. We can implement the AI algorithm on Raspberry Pi processors, and we can integrate it with a display so that we can have a small and handheld device for the development of such products. So the first thing that is required in the domain of AI is the game is all about the data. First of all, we must have the data in this field of research. Either it can be a I am talking in a generalized sense, so it can be in the domain of healthcare, either it can be a domain in the agriculture. So what are the means we want to have all variability in the form of data. So artificial intelligence, we can see that artificial intelligence, the machine learning is the subset of artificial intelligence, deep learning is the subset of machine learning, then comes the data science, and we also need statics visualization using the idiom. So machine learning is an application or subfield of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Generally, two procedures are being done. The first one is the training procedure, and the second one is the testing procedure. So it is a subfield of AI and aims to teach computers the ability to do tasks with data without being explicitly programmed. So once we have programmed our software, or the once we have programmed, then we can take the output n number of times. It can be used many times to take the output. We can use it uses the numerical and statistical approaches, like in the case of artificial neural networks, and models are being trained. The typical examples of machine learning algorithms are artificial neural networks, support vector machines, k nearest neighbor, and there are many other algorithms also. In the case of deep learning, they are complex architecture in compared to the artificial neural networks. They are computationally extensive, so they require more computation time, computational power, and the typical examples of deep learning methodologies are the basic architecture is convolutional neural network, followed by recurrent neural networks for time series data forecasting, and many other methods like LSTM, long short term memory. So these are basically the methods. So there is nothing fixed that you have to use this algorithm. Like suppose, for example, I want to classify something. So I can use n number of classification schemes. Like I can go for the artificial neural networks also. I can go for the support vector machines also. And nothing is fixed that this algorithm is going to give the best accuracy or this algorithm is going to get the best accuracy. So while once we have the data and we are into the machine learning domain and we want to, then we have to implement the different algorithms so that we can have the best accuracy, and we have to maintain that our classifier is not actually biased. So we will have one by one, we will go what are the different procedures, what factors should be taken care of, and how to develop a generic AI model so that it should be more effective when we give the independent data other than the data what we are using from the databases and other data. Other terminologies include data mining. It is a practicing of examining large pre-existing databases in order to generate new information. Examples are videos on YouTube searching. Technologies. Cloud computing refers to the use of a network of remote servers to store, manage, access, and process data rather than a single personal computer or hard drive. The typical applications include the telemonitoring applications. So these are the actually different applications of artificial intelligence in the domain of agriculture. We can have the idea of crop yield production and price forecast. For this, again, we require data of 5 years, 10 years. The more amount of data we have, and there should be a good amount of variability in the data. Of course, we can have a prediction about what amount of this crop we are going to get this year in India, or what can be the expected price of that crop in this year or in the next year. So these all predictions are based on the past data. The more amount of data we have, and the data should be more variable. There should be a great variability in the data. The data should not be similar, means the data should not be repetitive. Then we can have intelligent spraying. So this example we will see in next couple of slides. Then we can have different predictive insights. Agricultural robots are there for different applications for picking the uh, different vegetables from the plants. We can have the crop and soil monitoring. We can also do the diagnosis of different diseases that are being currently occurring in the crops of a farmer. So the today's lecture will be mainly focused on the disease diagnosis part, which is a typical great application of AI in the domain of agriculture. So next, in the domain of agriculture, the next important term is IoT. Today we are looking at the different drone-based technologies. They are capturing the, we are integrating a camera with that to capture the different photos of different leaves of the crops. So the term in IoT or the Internet of Things was coined in 1999 by Kevin Aston, co-founder and executive director of MIT Audio ID Laboratory. And basically it refers to a network of physical devices and objects that are embedded with sensors, software and network connectivity that allows them to collect and share data. So basically what this IoT technology does is it connects a number of devices to it. So a network is created. The moment a network is created, then other physical objects are required like sensors, which basically captures the data. Then it circulates into the network, and where we want to throw the data finally, or where we want to capture the data, that can be collected and shared both using this IoT technology. So this is a typical weeding robot in the domain of agriculture. These are smart agri robots which use the digital image processing and through the images of weeds in their database to detect similarities with crops and weed and spray them directly with their robotic arms. So basically this weeding robot, what it does is it collects the data and it compares the data with the database and it tries to find out the weed. And once it is found, it sprays them directly with their arms. With increasing number of plants becoming resistant to pesticides, they are a boon to the environment and also to farmers who spread the pesticide throughout their farm. An estimated 13,000 kilogram of herbicides are applied at a cost of 1750 crores each year, thus reducing the overall cost. Second part is machine navigation. It is a typical example with the remote controlled toy cars that can be also sent in the fields for collecting the data. Harvesting robots, utilizing agri robots to pick crops is solving the problem of labor shortages. Working with the delicate process of picking fruits and vegetables, these are innovative machines and that can operate 24/7. So, and finally, the drones in the domain of agriculture. So drones are used to enhance and optimize farming activities such as crop monitoring, crop sparing, soil analysis, and mapping. As agriculture is the most major sectors in the nation, they are equipped with sensors, cameras for imaging, mapping, and surveying farms. These are also known as the unmanned air vehicles, and the drones are controlled remotely. They can fly automatically through a software flight plans in their embedded system. The only drawback in the case of drones from my side is the use of battery. So we can't go for 4 to 6, more than 4 to 6 hours of, means we can't operate more than that. So we can have camera integrated to it, and we can have the health of soil. We can have the how much amount of moisture is there in the soil. So we can gather different data from the use of drones. And remote sensing is also being done using different sensors. We can put the sensors on the ground to collect different types of information from the soil. So crop monitoring, weather conditions, soil quality can be done through the remote sensing operations. And finally, computer imaging. So we can basically capture the data by using the drones. And then we can do some amount of digital image processing to detect different type of diseases if we have. And basically it will be compared from the database. And finally, we can be capable of detecting the diseases in the crops. So now completely coming to the agricultural domain, as India is one of the major players in the domain of agricultural sector worldwide, and it's the primary source of livelihood for about 58% of India's population. India has the world largest cattle held, largest area planted to wheat, rye, and cotton, and largest producer of milk, pulses, and spices in the world. So these are the different data. Consumer spending in India will return to growth in 2021. The post-pandemic led construction expanded as much as 6.6%. According to the media, the agricultural sector is predicted to increase to $24 billion by 2025. Rapid population expansion in India is the major factor driving the industry. And in accordance with this, the market is being stipulated by the growing adoption of the cutting edge techniques, including blockchain, AI, geographical systems, drones, and remote sensing technologies, as well as the release of e-farming applications. So basically, we want to integrate the new developed technology, or what I call this as a digital agriculture, with the traditional agriculture, so that the farmers can take the advantages of these new technologies. So the basic problems of the farmers are they have to cope up with the climate change, soil erosion, biodiversity loss. The effects of climate change affect farmers' ability to grow the food we all need, increasing volatile weather, more extensive events like floods, droughts, change in growing regions, limit the availability of water, weeds, pests, fungus, which reduces the overall crop productivity. They have to satisfy the consumer changing tastes and expectations, meeting rising demand for more food of higher quality, invest in program productivity, adopt and learn new technologies. This is also a bigger problem for the farmers, as they are not more educated. They have to stay resilient against the global economic factors, inspire young people to stay in rural areas and become future farmers. So what is the objective? The objective is there is no complete solution for farmers on which they can rely. So the basic objective, as I discussed earlier for the today's lecture, is we want to develop a complete end-to-end solution for the farmer. The farmer has not to do anything for getting the at least feedback from a solution. So we want to develop an automatic solution for generating advisories based on our detection. The development and integration of AI-based and pest detection module that is in the form of Android application. So after this objective, we will see that how we can, what are the different steps involved in developing a complete generic AI model. And the second step is the deployment of this solution to the farmers, because everyone is not capable of running the Python code or C code. So it is obviously feasible, or it is obviously good that anyone who is not more educated is capable of using your solution. So as I have discussed earlier, in today's lecture, we will focus more on the disease diagnosis part first. Second, I will show that how this solution is integrated to a server, a cloud-based technology, how we have created a database. And finally, we have developed an Android app, and we will see one by one that what are the different phases and stages in developing and complete end-to-end a solution. So first step to start with in the domain of AI, either you are in the domain of agriculture, either you are in the domain of healthcare, in any domain you are working and you want to have implement the different algorithms of AI or machine learning, deep learning, the first and foremost thing which is required is the data. In today's lecture, I have shown only the experiments performed on the database that is available in the online system, which is open source database. The name of the database is Plant Village Dataset, and it contains 54,305 leaf image samples with 38 classes spread over 14 crop species and 26 diseases of different crops. Secondly, what we can do, those who are working in the domain of agriculture and they have an access to the field or farms, they can buy, purchase, or take the drone on rent, and they can fly it, they can integrate a camera, and they can collect and prepare their own database. So technically, from the researcher side, you should always have some samples of a real-time data set. And we will see one by one what different problems we face when we take the data from the database and we take the data from the practical fields or farms. So let us start with the samples which are available on the database. So it is developed with 6 augmentation techniques such as scaling, rotation, noise injection, gamma correction, image clipping, and PCA-based color augmentation. These augmentation techniques were applied to the dataset to create a diverse dataset with different background conditions. So what you are going to find that these different samples are of different sizes. So they have to brought to one constant size. So the first thing we do with all the samples is we make them of a uniform size, and in our case, we have compelled that the size of the data set, data samples or the data is fixed to 256 by 256 pixels. Anybody can use this data set. It is open source database. Just you have to cite while you are publishing the papers. So these are the different samples you can see. It contains the apple leaf, blueberry leaf, cherry leaf, corn leaf, grape, orange, peach, pepper, potato, raspberry, soya bean, strawberry, etc. and etc. So this is the data that is taken from the database. One example I will try to show you here, if I have the data, that while you will be visiting the farms, the first problem you will come up with, for a single crop, the image that you are going to capture, it will consist of more than one images, more than one leaves, sorry. Here what you are finding is each leaf of different crop. But while you are capturing the data from the field, a single image will consist of, it can be minimum one depending on how the data is being captured. But in general, while collecting the data, you are going to capture more than one leaf. Now you have to decide that which leaf you are going to process for the final detection of the disease. There is a possibility that in the image, if there are 6 leaves, the image of the leaf that you are trying to capture contains no disease, while the leaf that is beside the leaf that you are trying to capture may contain some kind of diseases. So that you have to decide first of all that which single leaf consisting of an image you are trying to have the uh, you are trying to process that. In this case, we can see again that there are different leaves, and single image contains single leaf having a broad background which is contains no information to us. For example, any leaf that we contain contains a foreground, that is the leaf, and the background which is grayish in nature. So that background is not relevant to us. So these are the different problems. And what the people do actually with the data set is they take the data, they directly go and write the code for training and testing. They train, they get a good accuracy, 90-95% accuracy. But when they are going to put a sample from a practical collected data, then the accuracy is going to decrease drastically. So these are the different problems that I am discussing one by one that you are going to face. Because we are talking about not publishing papers, we are trying to develop complete to complete end solution. So publishing papers on a practical online data set is very easy. You have to do nothing. Every standard methods are available. You have to just code it and write papers. You have to find out some of the novelty in your approach. That's it. But the same model may or may not give you good accuracy with a practical data set. So one of the major challenge in the domain of agriculture is this, that a single image will contain multiple images. So you have to segregate the main leaf out of that image. First thing. Second thing, the background of the image will always come in the image. So while we will be capturing the different features from the image, the features of the background will be also captured for further classification using machine learning or deep learning techniques. So what we do is, in the second part, we do the pre-processing of the data. In the pre-processing of the data, there are different techniques that we can explore. The first one is the data cleaning, dimensionality reduction, feature engineering, sampling data, data transformation, imbalanced data. So if we skip the data pre-processing step, it will affect your work later on when the applying this data set to a machine learning model. Most of the model can't handle missing values. Some of them are affected by outliers, high dimensionality, noisy data. So by pre-processing the data, we are going to make the data set more complete and accurate, because we can also we actually also do the filtering to remove different kind of noises associated to the images. So this phase is very much critical to make necessary adjustments in the data before preparing an actual data set for training and testing, or before putting it to the machine learning model. So what I believe is 80% of our work is the data preparation, which will ensure that the quality of data which we are using will actually give us a more generic or a more reliable AI model or a machine learning model. So these are the different techniques involved. So we can reduce the dimension of the data, we can clean the data. We can use filters also, we can use different salt and pepper noise are there. So we can have different kind of filters. We can go for median filtering. Different approaches are there. One thing is, depending on the type of data, you have to use different methods. It is not possible that one method will work on one data and the second method will be working on the other data. So actually, it is a hit and trial process. If you have a data from a different source, obviously its resolution will be different. The sensors used for capturing the data will be different. So while the reception of the data, either it is a sensor of ECG, EEG, or we are talking about the different camera resolutions, different kind of noises, different resolution will end up with different data cleaning techniques, or the different transformation, or different methods have to be used. And then after we have to check that the method that we have used is good or not. So we have to apply the filter on any data, and we have to check the result whether there is some amount of, whether more amount of information is there in the output data or not. So another problem what the people face is the imbalanced data. There are different techniques. Suppose we have, so let us go for a binary classification. Different data of two different categories. The first data may consist of 4 diseases. Like if the agriculture people are there, they may understand that suppose we want to identify the different diseases in the rice and wheat crops. So there are 4 diseases in the rice crop, including the normal one, and there are 4 diseases in the wheat crop. So there is a possibility that in all of the 4 folders or all of the 4 diseases, you may not have same number of sample data. So different methods are there, SMOT is there, sampling data is there. You can go for augmentation also, so that we can increase the number of data with equal variations. One of the most important aspects of the data pre-processing phase is detecting and fixing bad, inaccurate observation from your data set in order to improve its quality. This technique refers to identifying incomplete, inaccurate. Sometimes a database may consist of duplicacies, so we have to remove that, because duplications may increase the training time of the machine learning model. Further, no further features are being extracted from that data. So it is obvious that the data that has to be prepared, the sample that has been used to prepare the data should not be duplicated or irrelevant or null values in the data. After identifying these issues, one, we need to either modify them or delete them. The strategy that one should adopt on the problem domain is goal on your project. So usually noisy data refers to the meaningless data in your data set. Either it can be an incorrect record or duplicated observations. So we have to remove that, and we can use filters. An outlier can be considered as a noise, even though it might be a valid record depending on the outliner. Once need to determine if the outlier can be considered noise data or if you can delete it from the data set or not. So actually, all these things are plug and play. You have to do it, and you have to check it step by step. A common technique for the noise data is the binning approach, where you first sort the values, then you divide it into bins, means bucket with the same size, and then apply a mean median in each bins, thereby smoothing the data. The third approach that is involved is the image enhancement method. So basically, we collected the data, we have pre-processed the data, means we have removed the noise, we have resized the data, we have made the data set balanced, we have used the augmentation techniques, and in the image enhancement method, we want to increase the quality of the images. There are various techniques. There are various techniques in which we can improve the quality of the data. So one of the most common approach means what we have experimented in our this while performing the experiments is the contrast limited adaptive histogram equalization, the CLAHE algorithm to equalize the images. So basically it is based on the histogram equalization. So while you will go through the basics of the histogram equalization, what you are going to find is you will have a structure of this type. Y-axis stands for the histogram and the x-axis represents the number of pixels in each of the images. So it is a variant of AHE adaptive histogram equalization which takes care of the over amplification of the contrast. It operates on small regions in the images called tiles rather than the entire image. The neighboring tiles are then combined using bilinear interpolation to remove the artificial boundary across the images. This method is also applied to improve the contrast in the images. We can also apply it to the color images also. It is applied on the luminance channel and results after equalizing only the luminance channel are much better than equalizing all the channels of the BGR image. And these are some of the results in an image enhancement. So this is the original image, then we have converted into its a binary form. So we can look this as, this is the original image, it is being converted into black and white or the grayish image. So you can look, you can interpret this result as the background is also gray and the leaf on the background is a bit dark. So while you will be segmenting the image, it will be difficult. So this is a multimodal histogram that is being generated. And if we want to use different thresholding or the image segmentation algorithm, there will be a problem. So what we do is after enhancing the images in the colored format only, we try to get back to the segmentation of the images. So in the image segmentation, what happens? We want to separate the background and the foreground region. Means we want to remove this background and we want to have only the leaf part of the image for further feature extraction and classification process. Again, I would like to highlight that there are several image enhancement methods, and the objective of this enhancement method is to improve the quality of the data or the image spatially. There is no such fixed approach. There is a possibility. While I was in the previous lecture of the sir, and one of the student has asked that whether the image enhancement method is going to degrade the, not actually degrading, but maybe, so the objective of this image enhancement method is to highlight the abnormalities in the data what we are trying to find out. So what will happen if you are using different method? There is a possibility that method will not work on that data that you are using. So you have to just experiment or go through the different method also. And after looking at the output data, whether the disease or whether the spot in these leaves is being clearly identified in the newer image or not. So starting from the step one point I am highlighting is no fixed step is available that we can say that this method is going to perform well on each and every data or each and every sample. So we have to experiment the different methods on the different data, what we are having. So coming to the image segmentation step, Why? The first question is why it is important. So basically, in the final stage, when we will be going for feature extraction and classification purpose, we will take this image as the input image, and what will happen is the background region will also be captured in the feature extraction. So will happen, this background region is available with all the different samples. Suppose that this background region that is visible to us is around 30 to 40% of the complete picture, and the other images is also having the same background with 30 to 40% of the background. So while in the classification stage, what is going to happen, this feature vector consisting of the background will actually be confused with the data of the other crop. So that has to be removed. This will be identical if such background is identical to the different crops or the different diseases of the data, then it will create a problem. Therefore, image segmentation is also an important step while developing an AI model in the domain of image classification. Image segmentation is a computer vision technique that partition a digital image into discrete group of pixels, image segments, for object detection and related tasks. By parsing an image complex visual data into specifically shaped segments, conventional image segmentation algorithms process high-level visual features of each pixels, like color or brightness, to identify object boundaries and background regions. Sometimes what happens that you may not be able to detect the reason that you are means you cannot be able to detect this boundary in the image. So one simple example is used of the machine learning techniques, and you can manually annotate the boundary of the leaf. In our case, you can prepare a data set for that also. You can apply machine learning on that annotated data set on which you have created a boundary around the leaves, and you can train it, and you can take the leaf out and you can leave the background back in this case. In the D column, we can see that the leaf part has been taken out and the background is left. So that part we are not considering for finally feature extraction and classification. That is the main objective of our image segmentation step. The typical conventional image segmentation algorithms are edge-based segmentation, region-based segmentation, thresholding-based segmentation, which are local, global, adaptive, optimal, region splitting and merging, and many more. So after being the image segmentation algorithm, many masks are available like UNet. Many pre-trained models are available for segmenting these plant leaves. You can find them on Google also. In the case of chest X-ray classification also, UNet pre-trained UNet models are available so that you can easily segment the leaves or from the background. So this was a completely, it was converted into its binary form. And finally, the leaf is being taken out in the C column, in this column, and the background is left behind, so that this may not create any kind of confusion, because if we will consider this, we are going to take this as a feature in the final classification stage. So this is a complete end-to-end procedure done by our one of the students in our laboratory, BTech student, and he has just selected the image. He has done the noise removal using some median filters, and number of filters are there. Then after he has done the contrast enhancement, he has done the masking, and this is the finally the segmentation images has been taken out with a precision of 94.6%. And recall, so precision and recall are the parameters for evaluating the algorithms. So that we will discuss in the last. This is another example, step-by-step process. This is the original image. The noise has been removed. It is converted into, here a machine learning k-means clustering has been used. Means a mask has been generated using that, and finally we can see that the background has been completely dark and we have taken the leaf out of this final image. After being the images are being segmented, means we are taking only the foreground or the leaf out of this image. We are passing it through the feature extraction and classification methods. Again, these are two different parts. In the feature extraction, we want to extract the features of the specific regions. Like if we are trying to detect the disease part, suppose this is the leaf and we are trying to detect the reason on which is leading to a particular disease, then we have to focus on these regions where the leaf has any kind of abnormality than the normal. So the basic aim of the feature extraction approach is to extract the features of the specific parts so that our ML model or the machine learning or the deep learning model can have or can easily separate or identify between the different diseases. So different feature extraction methods are also available in most of the papers. Depending on different data, you can go for principal component analysis. It is basically a feature dimensionality approach also, but you can use as a feature extraction approach use also, both. And you can go for the different transform based approaches, like you can go for the fast Fourier transform, MFCC. Depending on the different type of images, different papers have been published, and followed by the classification methods. Again, the classification method implies the machine learning or the deep learning methods. But in today's presentation, both this feature extraction and the classification part is accomplished by the CNN model. So basically the CNN model does both. It extracts the features also, and in the fully connected layer or the before the output layer, it extract the features, and in the fully connected layers, it basically the classified the input vectors into different categories. So a typical CNN architecture consists of an input layer, here the input layer represents our input data, followed by the convolutional layer, pooling layer, and the fully connected layer. And finally, we get the category of the output. So in the convolutional layer, they are made up of filters that are being applied to an input image. The output of the convolutional layer is a feature map representing the input image with the filters applied. Convolutional layers can be stacked to create more complex models, which can learn more intricate features from images. Followed by the pooling layer. Pooling layer reduces the spatial size of the input, making it easier to process and requires less memory. Pooling also helps to reduce the number of parameters and makes training faster. There are two main types of pooling, the max pooling and the average pooling. Anyone you can use, and you can check the results based on that. And followed by the fully connected layer. They are one of the basic types of the layers in the convolutional layer. In each neuron in the fully connected layer is fully connected to every other neuron in the previous layer. Fully connected layers are typically used towards the end of CNN, when the goal is to take the features learned by the previous layers and use them to make predictions. Again, coming to the back slide, before the fully connected layer, this part represents the feature extraction parts, and this fully connected layer and the output layer stands for the classification part. So for publishing papers, what the people have done is they have extracted the deep feature also, and they have changed the output layer. You can replace the classification part using the SVM, KNN, or any of the machine learning algorithm like decision tree or any method you are trying to approach. Or for publishing paper, what people have did is they have removed the first part, they have extracted the different features using different methods, and they have classified using CNN. So both the things are possible from the technical background. But this complete CNN, what I want to highlight here, it is does both the feature extraction and the classification part also. So the history of CNN is a very old one. In uh, 2000, there are different actually architectures of CNN, LXNet. I will just highlight the name of some of the important one, like LXNet, VGG, GoogleNet, ResNet, UNet, DenseNet, Fast RCNN, and R2U net. So if anybody is interested in implementing some algorithms other than the conventional CNN, in the case of deep learning, you can go for LXNet, VGG, ResNet, UNet, and you can have a brief comparison of all these methods, and you can look at that what accuracy you are actually getting. So basically in the CNN algorithm, there are two phases. Once the features has been extracted, in the classification part, it consists of the training and the testing phase, in which fine tuning and the training of the features that has been extracted is being done. And finally, in the testing phase, on the test data set, as you all know, the data set is split in two parts, the training set and the testing set. The ratio of the training set and the testing set may vary on the experiments that you perform. You take 80, 20, 90, 10, 50, 50, 70, 30, as per your wish. And these are some of the results that we have highlighted regarding the feature extraction using CNN. And we can see that these are different features that has been extracted using this input leaf, and these are the different features extracted using the different layers or the different filters, you can say. We can say the kernels or the different layers of the CNN. So A is the real image, B is the first convolutional layer filter, which is being multiplied by the input. C represents the rectified output from the first layer. D represents the second convolutional layer filter. E represents the output from the second layer, output of the third layer, output of the fourth and fifth layer, respectively. Followed by the classification part, we can see that in this figure, we have also implemented the segmentation stage. So what we have found out that the output comes with a confidence score that you can see that there is some values like 0.998 or 0.87 or any value will appear that highlights the confidence score of the model in detecting a particular disease of a particular or a particular class. And it will also highlight the region using a bounding box that for what reason this input is being classified to a particular class. So one can verify also, suppose we are talking in the domain of agriculture, so a agriculturist or a plant pathologist can have a easy approach and he or she can verify that whether it is of a particular class or not, means whether the results that you have obtained is good or not. So coming to the experiments and results, the size of the images of were different sizes. So we have made them uniform to a 256 by 256 matrix. A basic model was trained to separate the normal and the disease plant crop. and a basic convolutional neural network architecture was used in our work. So the optimizer that was used was Adam. We have gone for 100 epochs. The batch size was 16, learning rate. That is all based on experiments. There is a possibility that you may get the best accuracy at 50 epochs. So that you have to check, and that can be only, we can come to a conclusion by performing the experiments. So talking about the results in a more technical manner, the training data set consisted of 700 samples of apple, cherry, corn, grape, peach, pepper, potato. And in the training data set, we have considered 300 samples only in each of the different classes of apple, cherry, corn, grape, peach. So in total, the training data set consisted of 4,900 samples and the testing data consisted of 2,100 samples. So in total, we have experimented all this result on 700 samples. So this is the brief discussion about what was the different number of diseases in each of these crops. And finally, we get a confusion matrix, which decides our accuracy. For example, we have classified, means we are classifying 3 classes. So a confusion matrix stands for n by n matrix. It is a n by n matrix that highlights the category of a particular sample falling into a particular class. So suppose if we are doing a classification for 3 class, so it will be a 3 by 3 matrix. If we are going for 5 classes, 9 classes, or 20 classes, then it will be a 20 by 20 matrix. Secondly, the diagonal parts in the matrix represents the true positive. True positive stands for the total number of correctly classified events of a particular class. And if we consider the column, then we can see that a total number of 80 samples were there. Let's say the name of the class was A. So the accuracy of the model for class A is 75 by 80 into 100. And we consider this 5 samples as a misclassified event or false positive in our case. In the second case also, we can see that no sample was classified in the first category. 388 samples were classified into category B. Since this row stands for the category B and this 2 represents the category C classification, and 17 samples were misclassified out of 388 plus 17 samples, and it has been misclassified into category C. In the third row, a total number of 92 samples were correctly classified and 4 samples were misclassified into category B. Other than the parameters that we are going to calculate, precision and recall, after looking this matrix, we can understood this as some samples in category B and category C were so close or identical that the features that we have extracted for those samples, our trained model is not capable of identifying this 17 samples and these 4 samples, so they are actually misclassified. So using different methods, if we add more number of features to our model, there is a second thing that we can do. We can have more number of features. We can have the statistical features also. We can just integrate and put it into our machine learning model, and we can try to increase the accuracy. Talking about the false negative part, it is total number of the misclassified events of a particular class, and true negative stands for the total number of classified or to any other classes. So this is the formula: true positive by true positive plus false negative stands for the precision. It is the correctly detected events among the total number of events, and recall it is the rate of correctly classified non-events. So in our case, the accuracy on the publicly available data set was 94.12 and 95.63% as a recall. In the second experiment, just it is a delivery that I am trying to highlight here. In this case, we are having 5 classes. So we can basically see that we have just drawn a 5 cross 5 matrix, and the interpretation for this matrix will again remain same. So the correct classification, we actually, what we again increase the number of samples to improve the accuracy. And in total, we have taken 1,13,827 samples. Of course, some of the samples were taken from outside other than the database. Some of the samples we were having previously. And we end up with 97.37% and error rate of 2.63%. These are the comparison of the different testing accuracies during the optimization process. And these are the different training accuracy and testing losses. So we can see that the training accuracy is actually gradually increasing once the number of epochs are increasing, and the testing accuracy is also increasing in relation to the number of epochs, which in our case was set to 100. Then again, we implemented the different methods, what I was discussing earlier in the case of CNN. We implemented the ResNet 18, ResNet 50, SqueezeNet, DenseNet 161 architecture, and we end up with 86%, 89%, almost 90% precision, and accuracy of around 98 and 99%. We end up with different architectures. So basically, different architecture, different methods for different problems are available. You have to identify the problem, you have to implement different methods, you have to check the results, and then only we can say that we are having a good result. And finally, first of all, we developed a GUI in the MATLAB. So we have taken the input leaf image, we have done some pre-processing, we have segmented the image on the on the right side. And finally, the classification result of this leaf came as early blight, one of the classes. So this was all about the AI methods that we have implemented to detect the diseases. Once we have detected the different diseases, we want to give this technology to a common man who does not know anything about the coding, who does not know anything, just it should be a app type, or it can be a software or something in a product form, so that it can be easily used. So what we did is we developed an Android app architecture. So its front end was developed in the HTML and backend was developed in Java. The AI model was developed in Python. And for preparing or for forming the database or for creating the database, we use the PHP and MySQL languages. So what happens in the app is after opening the app, it will ask for your location and your different permissions, like the app want to access the data of the phone, and she can access the location. After clicking on that, you have to select the language. After selecting the language, you have to just upload the image of this crop leaf. In our case, today we have developed such a system that if you will upload multiple images also, it will give result of only one leaf only. So we have to be careful while putting the data on the app. And this app on the client side is being sent to the AI model, which is on the server of our institute. It compares it with the database, and a WhatsApp message is sent along with the recommendations that what amount of water or what amount of pesticide in how many days that you have to spray on your soil or farm or land. So this WhatsApp message part is just developed in the database. Further, we are also enhancing our database. The different in the different districts of Bihar, different people are available. They are uploading their data daily on a daily basis. The code is written in such a manner that you have to select the type of crop, and once you have select the type of crop, it will go into a particular folder. It will compare the data that has come, and after giving the result, again the model is being retrained. So on a weekly basis, we are having more amount of data and we are increasing our training accuracy. Means our objective is to increase the training accuracy. So this is the basically GUI of our app. You have to enter your phone number, name, district, and you have to click on the camera, or if you have a if you have means you have an image from your side only, then you can upload it. And finally, the recommendation will come on your mobile phone in the form of WhatsApp message. If the internet is slow or the server is slow, it may take 30 to 40 or maybe 1 minute, 40 seconds or 1 minute. And finally, coming to the conclusion part, each of these steps, what we discussed today, like data collection, what factors that has to be taken care of, means the resolution should be same, the instrument there should not be variation. So all of these 5 steps, the data collection part, preprocessing part, enhancement part, segmentation part, and feature extraction and classification part, each of them has to be utilized in a proper manner. You have to check for different values of them. Different method has to be explored. And then after we can come to a conclusion that, okay, after looking at each of the results, not only what training and testing accuracy we are getting, you have to also see the results in a step-by-step manner, because there is a probability that your classifier may be biased. So obviously there are different techniques for that also, but due to the limitations of time, I am not going to that, but I can recommend some methods that can avoid the biasing of the classifier. You can go for k-fold cross validation technique, in which you have to means fix the value of k. You can go for 5 or 10-fold cross validation. What happens in that is, suppose you have a data set of 10,000 images. So basically it will create a 10-fold. So one fold will consist of 1,000 images. So 90% of it, means total 9,000 images, will be involved in training, and the 1,000 images or one set or subset will be fixed for testing. So what will happen? This will repeat for all the 10 subsets of data. And finally, the testing accuracy for each of these folds will be taken averaged, and we calculate the final accuracy of the model. So that will give us a more generic, or we can assume that the accuracy that we get after performing the k-fold cross validation technique on the data set will give us a reliable accuracy. So in the conclusion part, we have implemented different methods. We have explored many methods, and we have till now we have obtained an accuracy rate of 96.7% and a precision of 95%. To illustrate the performance, several comparisons of different input and loss functions were shown. So if you have any questions, I will try to answer them all. This is the end of my presentation. Still, I have, I think, 10 to 15 minutes more. 10 minutes.
Sir, good evening, sir.
Yes, ma'am.
I have one question, sir.
Yes, ma'am.
You have listed so many methods of CNN architecture.
Yes, ma'am.
Among that, you have implemented some 3 to 4 methods for testing your classification.
Yes, ma'am.
Is that enough that for any classification thing we are taking regarding CNN, is that enough that we can limit our comparison with some 3 to 4 methods, and we can say that our proposed method is good enough like that, sir? Because I have used ResNet based method for classification of brain tumor into some 9 different classes. I
Yes,
have
ma'am.
compared the ResNet with AlexNet, VGGNet, like some 3 to 4 standard methods I have compared. And I am defending that my method works well since it gives some performance accuracy compared with other methods. Is that sufficient, sir? Or if any other cases, if someone is asking why you have not compared with other methods, how to defend that or how to justify that, sir?
Ma'am, actually, it depends on the. Actually, this is a common comment what the reviewer sent to us, that why not this method has been used or why not this method has been used. So, to be
Yes, sir.
very frank and to be very clear cut,
Uh,
what should I suggest is you can go for the implementation of that method and you compare the accuracy of that method to your implemented algorithms, because
okay.
there are n number of algorithms. I also don't know the,
Mm,
you also don't know that which algorithm will perform better.
mm,
But
yes, sir.
this is a common question of the reviewer, that suppose you have a very good question you have asked, that this is a very common question that nobody can say that which method is better. In my presentation only, somebody may say that, sir, I have implemented some of the transform based feature extraction technique and SVM, and I have I have obtained a higher accuracy than you. It is also possible.
Yes, sir.
So the best idea is to implement that method and compare it with the your existing methods, what you have implemented.
Yes, sir. Thank you, sir.
Thank you, ma'am. Any more questions related to the, yeah, to the agriculture domain?
Is there any question for sir? Oh, I feel done. Uh, now, thank you, Dr. Sandeep Raj, Professor, Department of Electronics and Communication Engineering at IIIT Bhagalpur, for your enlightening lecture on agriculture. Your comprehensive presentation shows us the diverse application of machine learning and emphasizing both on narrow and general artificial intelligence and the machine learning applications across the various sectors. Particularly, you have focused on the agriculture. So I observed that it was really a informative presentation, starting from the very basic about the well-learned machine learning based predictive models used and pre-processing of the data and starting the features agricultural fields. You also focused how we will use this nowadays drone technology for the benefit of the agricultural sectors. We you also discussed in details about the computer vision image processing in disease detection in agricultural sector in details. You also detail out how this CNN can be utilized in these fields. Uh, I feel that your presentation helps a lot. We are deeply grateful for your expertise and the comprehensive knowledge you shared, which has inspired us to inspire these fields and also these machine learning strategies into our initiatives the interior initiatives. And thank you for a truly informative and inspiring sessions and your contribution to addressing practical applications in agricultural research fields. Thank you once again, sir.
Thank you, sir. Thank you for giving me the opportunity to deliver this lecture. Thank you, sir. Thank you very much. Thank you all the participants. If you have any doubts, you can directly mail mark to me. Thank you.
Okay, thank you to all participants. So tomorrow we'll also start as per our scheduled time to the short-term course. Thank you to all.